Hello my friends, welcome to Inside Out Electronic channel. This is Uncle Misha and today we have this. This is Sonoff TH Elite. So TH is temperature and humidity sensor. This is a little smart home device. It has temperature and humidity sensor. So essentially you can control any electric device by temperature and humidity, based on temperature and humidity values read by sensor. So as you see, this is a little package. So essentially it contains the Sonoff TH Elite, and as far as I understand, this is temperature and humidity sensor. So let's take a look in details what we got. It came as a package essentially, but you can buy sensor separately and the device itself separately. And I'll tell you why I got it. But so this is a temperature humidity sensor. As you see, this device itself, and it has a contact here. Okay, and this is TH Elite. So that's the smart device itself. It has also a screen, apparently, large button and few indicators here. So what do they have? So it has temperature and humidity monitoring, temperature and humidity history data graph, automatic mode, wet and dry contact. I need to figure out what that really means. Voice control, which probably through the smartphone, not just through the device. Timer schedule, LAN control. LAN control. Well, LAN. And screen display. Specification model THR320D, input 10 to 240, 20 amp max. Very important here, 20 amp max. What's in the box? Smart temperature sensor, humidity monitoring switch, and mounting base. And obviously it says it's compatible with Google Home and works with Alexa. Okay, so let's talk about first sensor, because that's just probably not gonna talk much about it. So the major differences between this sensor and the old one, so this is probably this connector. So this connector consists of 4 telephone sort of kind of looking wires, and this one is 2.5 millimeter TRRS pin, right? So that's the major difference. The only one thing which I don't know, doesn't say here, because here it says a lot of information. Okay, this is our song, IM2301 sensor, humidity, temperature, precision, digital one wire, serial number, even it has even serial number. So this sensor seems to be we know information about this guy. What the heck is inside here? I have no idea, but we clearly gonna take a look. Probably not now, because that's gonna be in the end. Okay, let's just leave it, put it to the side. Let's just get back to our sensor. So we have this Sonoff little thingy. How do we open it? Okay, it's a fancy packaging. Mamma mia, look at this, it's Elite. It's much more fancier. Nice. Okay, it's much heavier unit. Hope it's gonna have a proper beefy tracks and terminals. So here it says some documentation, and apparently there are three versions of it: THR3 Elite, R3 without screen, R Elite with screen. So sometime when you it has DIN rail mount. That's cool. I don't need it, but it's cool to have. I'm probably gonna remove it for now, because I will be pulling it apart anyways. A nice beefy unit. So right, they have dry contact. Normally open, normally connected. Common dry contact. I have to figure out what is this dry contact. 5 to 30 volt, 1 amp max sensor. What the fuck is dry contact? Okay, sorry, I never read the manual, but I need to understand what is the dry contact. Wiring method for dry contact. Способ проводного монтажа сухого контакта. What? Is this to power this device straight from... Yeah, from 5 volt, I guess? No, normally open, normally closed, common. No, this is not. I'm not following. Unless this is getting commutated by relay as well. So that's a possibility. So you can probably control some kind of... It commutates 1 amp, 5 to 30 volt, 1 amp. So yeah. So this is probably designed to switch on and off something else additionally to this device. Okay, so on the bottom here we have 4 terminals. I don't really see what are they, but looks like there are some big beefy screws right there. Oh, is this just opens up like that? Wow, what's going on here? Why it's so hard to get out, to remove it? Why? Well, it was actually easy. I had to actually, you know, do this as well. Here we are. So it's too small. Okay, those terminals looks much more beefier than. It's much more robust than what I have here. Okay, so that's good sign. Okay, well, let me take a look inside and we actually make even better conclusion what's going on. We're not gonna be powering up at the moment, we're gonna be disassembling it first. So after removing 4 self-toppers, it's apparently super easy to open. And here we are. We have 2 relays apparently. Okay, so there is 1 relay and there is another one. So yes, this is this dry contact business controlled by this relay. What kind of capacitor is that? Is this? Okay, so power supply seems to be more or less okay. And look at those contacts. Yeah, these look a little bit more beefier than these jaws, so I probably would trust it a little bit more. So let me dig a little bit further. So obviously we have serial here, which is clearly labeled 3.3 TX Rex and ground, which is nice. Here's capacitor is missing. Who knows, maybe I can add it just to make sure we have a little bit better operation. So primary 400 volt 105 C capacitor, 4.7 microfarad. It's a switch mode power supply obviously, and let me just unscrew a little bit more. So after removing 4 self-toppers, it's apparently super easy to open. And here we are. We have 2 relays apparently. Okay, so there is 1 relay and there is another one. So yes, this is this dry contact business controlled by this relay. What kind of capacitor is that? Is this? Okay, so power supply seems to be more or less okay. And look at those contacts. Yeah, these look a little bit more beefier than these jaws, so I probably would trust it a little bit more. So let me dig a little bit further. So obviously we have serial here, which is clearly labeled 3.3 TX Rex and ground, which is nice. Here's capacitor is missing. Who knows, maybe I can add it just to make sure we have a little bit better operation. So primary 400 volt 105 C capacitor, 4.7 microfarad. It's a switch mode power supply obviously, and let me just unscrew a little bit more. Alrighty, after removing another 4 tiny self-toppers and removing the antenna, okay, I can just pull this board out. So we have this ribbon connector right here, I don't know, rubber connector right here for the LCD. So LCD and antenna is completely self-contained. By the way, if you have like big beefy antenna, you can actually modify this guy and pull a ref connector right here and just add this one big antenna. You know what I'm talking about, right? So this is actually nice that have antenna connector. So there is no built-in antenna, I think. There is no built-in antenna. Okay, let's take a look a little bit closer what we have here. So a little bit zoomed in, and let's start from the power supply side. So we have, is this a fuse? This is the fuse apparently. Curious, what is that? I need to read up on this. This doesn't look like conventional fuse here. Okay, we definitely have relay which says 20 amp 250 volt. I'm not sure why they have this here straight on relay, but then we have safety capacitors here, we have resistor, and then we have capacitors, and we have two caps. So we have obviously the bridge rectifier, the primary controller which says LP3667. Obviously I don't know anything about it, but need to read up on it. Then we have two capacitors. One is 400 volt 8 microfarad, another is 400 volt 4.7 microfarad. A little inductor here. And what kind of brand is this? Kniszcza is this guy, and I have no idea what is this. Chiveo, this guy. Okay, well, and then we have Kniszcza, another Kniszcza 105C. All of them rated 105C. I hope that means something really. But yeah, anyways. So we have this safety capacitor between primary and secondary, I guess, for the reference, ground reference. So this is on this side. Then we have a relay. We have little transistors probably to drive relay. Then we have a serial connector. Then we have a USB, I'm talking about Wi-Fi, Wi-Fi connector right here. Okay. Then if we go any further, we have a beautiful ESP32. Yes, in comparison to this guy, which was using ESP86, in comparison to this guy, which was using ESP8266, one core, I don't remember how many megahertz. So this guy is using ESP32 dual core, 40 megahertz. So this is pretty good. This is voltage regulator, I do believe, and this is 32 megabit serial ROM right here. So this relay is rated 3 amp 250 volt and is driven by 5 volt DC. It's right here. But these contacts are limited to, I don't know if you see it, 150 volt 2 amps. So no more than 2 amps can go through here. And what does this guy say? They try to be as safe as possible. They say 1 amp. That's fine. Okay, here's our telephone kind of looking adapter. So let's take a look at another side. So on the back side here we have a whole bunch of discrete. So some of them probably are, what are those? It's a diode. This is transistor, probably to drive the relay. Not sure what is this. It's two chippies, U4 and U7. Not sure what they for. Really hard to say. A few inductors, probably, you know, maybe some voltage regulation because they have to make 3.3 volt or make some, I don't know, this kind of voltage is this guy. 5 volt DC. So this relay is driven by 5 volt as well. That's cool. Okay, it says here 5 volt DC. Yeah. So this is 5 volt relay. So this little guy right here, or no, not little, but big one, this is actually LCD driver. It says TM1621, but I think there is also a HM1621 kind of driver which drive 13 segment LCDs. or whatever segment it is. Is it 1320? Maybe I'm wrong. So anyways, I still need to find the documentation on this one, which is not as cool as this guy. So, and then we have here, I'm not sure, and probably this guy requires some separate power supply just for him. Then we have primary driver. This is all-in-one solution to drive the product. I don't see even MOSFET. Probably, yeah, probably this guy actually does the switching as well, and the diode bridge. So let's take a look at those beefy connectors right here. They, in addition to being, they are soldered. Okay, I don't know, can they carry 20 amps? They also reflown lots of solder in them on top of those tracks, so they probably gonna be a little bit more current capable. So this is line neutral, this is neutral wire go here, this is line in, and this is line out. So yeah, two neutrals together, line in, line. Oh, you know what I just noticed? This stuff doesn't have ground. Huh. So looks like your ground wire not gonna be coming here. So this this circuit is not grounded. Your ground wire gonna be just coming from your controlling device straight to your outlet. Yeah, it's gonna be just loop like this. It's not gonna be attached to this. So if you wanna deal with grounding, this is gonna be connected straight from your out socket. If you're gonna control something which requires ground, straight to your device. So yeah, bypassing all this jazz, not even connecting here, which is weird. I would say it would be nice to have ground here, but there is no ground. Okay, that's I think this is pretty much it as far as electronics go. I think those con terminals here are pretty beefy, so I would probably trust them. Unfortunately, okay, let me see how they operate. I need a bigger screwdriver than that. I see. Whoopsies. Oh, they probably need to. Yeah, here how they work. Yeah, I would want it to have something like, you know, you open the screw, you hook up your like a hook or a circle, and then you just, you know, tighten it like this, and that's it. Because this is again some kind of flimsy solution. I mean, that's still better than these jaws, I'm pretty sure, but that's, yeah, it's a bit flimsy to me. But well, let's see. Anyways, so I think we're done here. I'm gonna take picture of front and back, and then I will. Next one, I'm gonna take a look at this little dude, as I promise. How do you open it? That was turned out to be pretty easy. Shit, just like that. Hope I didn't break anything. So we have here a chippy. Yeah, just unscrew it real quick. Do you have anything on the back side? Not much. Ooh. Okay, this is VCC, data, ground. So it has two grounds, one VCC. Why do I need two grounds? Interesting. Only 3 wires are used. VCC, data, and ground. There is no. I don't know why I need 4 here. Only 3 are wired, but there is a RX, TX, and stuff like that. SDA, SCL. What does it have a microcontroller in here? It looks like it does. This is very interesting. This is not what I expect. Let's take a look what kind of microcontroller is there. Alright guys, this is interesting. So this little guy, a little microcontroller right here, turned out to be OB38R08A1. Is one tact machine per cycle, single chip 8-bit microcontroller, 8 kilobyte embedded program memory, and execute all ASM51 instructions, fully compatible with MCS51, whatever it means. But we definitely have a microcontroller. So this microcontroller apparently in this QFN20 configuration can have up to 20 GPIOs. This is amazing. And also, as you see, there is also some SDI-CL I2C pins available right here, which is pretty cool. No, what for? But either this can be extended to something else. What is this? It's this little chippy. It reads A1A 1R dot. So I assume this microcontroller is to drive and read data from this chip. And actually, let me show you the content of old a Sonoff sensor. So I thought this is super pretty basic until I looked in the bottom. So it turned out to be, it's not as simple just as well. It has some kind of chippy as well. So maybe this is another like simple microcontroller. I need to Google it up, search for now. But it is sort of similar, but different as well. So yeah, this is interesting. And obviously if it has 14 megahertz crystal, this guy apparently runs at 16. So that's this guy is supposed to be some sort of microcontroller. And yeah, some little bit more stuff around here. So yeah, this thing is a little bit more sophisticated than I expected. I thought this is going to be temperature sensor and it's Bob your uncle, and the 4 wires is good enough. But no, turned out to be this is more than I thought. And this doesn't run I2C, it runs something else. It runs just a one wire interface, single wire data, VCC and ground. And these microprocessors can work from 2.5 volt to 5.5 volt. So that's gonna be probably it for now. We've done a lot of tear downs at the moment, but we didn't power anything yet. Alright guys, I think that's gonna be it for now. We didn't power anything up at the moment, but we did just a lot of tear downs. My main concern was just to make sure these terminals are okay, and I would say they are okay-ish. Okay-ish. Still kind of weird ass solution, not standard. I would like to see proper screw terminals. You put your terminal on a wire, you plug it in, you screw it in, it's just gonna hold very well. This kind of stuff, meh. Okay, I'll give it a try and see how it's gonna work. At least the contact here is supposed to be a little bit better than it was in the other solution. So that's gonna be it. I'm gonna share some photos of all my findings with you on my website. You can actually look in details what we have here. Alright, thank you guys for watching. See you next time. Stay tuned and stay safe. And just to show you that it works, here we are. I plug it into mains, connected it to mains, and we have here 20 degrees C, 21 degrees. I was just breathing into it. The humidity really went up and temperature a little bit. Yeah. So, oh wow, look at this. So yeah, it's actually reacts to my breathing, and here we have 100% humidity in 24°C temperature. So I'm not sure how can you change this device between Fahrenheit and Celsius. Probably you have to do it through the phone when you connect it, when you pair it to the phone. But so far so good. This device works. It clicks when you press the button, and I guess those things gonna indicate then they are it's operational. It's on, it's connected to Wi-Fi, and this one I'm not sure what the heck that's supposed to mean, but it works.